There are two things that you need to know about absolute value. The first thing is that absolute value is the distance the number is from 0. So how far is 5 from 0? 5 units. How far is -7 from 0? 7 units. The second thing you need to know is that distance is never negative. You can drive 2 miles. You cannot drive -2 miles. If you throw your car in reverse and reverse for 2 miles, you still went 2 miles. You just drove 2 miles in reverse. Good luck actually getting to that without, something terrible happening. I feel like that's a very, very unsafe thing to try, so don't do that. So in part A, they're asking the absolute value of x equals 10. They're basically saying, where on the number line are you 10 units away from 0? You're 10 units away from 0 at 10. Where else on the number line are you 10 units away from 0? At -10. This type of absolute value equation has two solutions, +10 and -10. For part B, where on the number line are you 0 units away from 0? At 0. Is there such thing as -0? No. So there's just one solution there. For part C, where on the number line are you -1 units from 0? What did I say in number 2? Distance is never negative. So can the absolute value of something equal a negative number? No, there are no solutions. And you may want to add to your notes that absolute value of stuff cannot equal a negative number. Your first step when solving absolute value equations is going to be to isolate the absolute value. You want to get the absolute value to be completely by itself before you do anything else. So what should we do first? Subtract 4. So we have 3 times the absolute value of 2x minus 5 equals 3. Another thing you need to definitely know, no distribution into absolute value. Absolute value is kind of like a set of parentheses, except you can't distribute into it. So we cannot distribute the 3. We need to get rid of that 3 in another way. This is 3 times the absolute value. How do we undo times 3? Divide by 3. So the absolute value of 2x minus 5 equals 1. Once you have isolated the absolute value, now you need to split this into 2 separate equations and solve both equations to get your 2 answers. Those 2 equations are stuff inside the absolute value bars, 2x minus 5, equals 1. So notice that equation looks exactly like the original, but without the bars. And anyone know what the other one needs to look like? 2x minus 5 equals -1. Take a moment and solve both of these equations. Your 2 solutions are x equals 3 and x equals 2. It will often say check your solutions. Honestly, if you have absolute value blah blah blah, absolute value blah blah equals a number, you don't really need to check your solutions. If we plug 3 in here, if we plug 2 in here, both of them will make that equation equal 7, so everything will be fine. this example, to set up your two equations, you don't have to do any pre-work. There's nothing in front of the absolute value bars. There's nothing after. So what are the two equations? Awesome. One thing I want you to notice is that the left side doesn't change. The left side stays the same for both equations. It's the right side of the equation that changes to make those two equations. What would you do in both of these as your first step to solve? Multiply by 5, then you'd probably subtract by 3, then you would divide by 2. Okay. Do you feel like you could do this the rest of the way yourself if you needed to? Okay. Let's move to the next example because this is where it gets a little bit different. We need to write two equations, one positive, one negative, and we need to check our answers because there's the possibility for extraneous solutions. Extraneous solutions are solutions that mathematically they're fine. The process that we use to solve them makes them appear to be solutions, but when we actually use those solutions, they don't really work in the original problem. Okay, this example is different because two reasons. There's an x on the right side, and there's absolute value on both sides. Your first equation is going to look exactly like your original equation, just without the absolute value bars. So don't change anything on the first equation. Stuff equals stuff. 3x minus 4 equals 7x minus 16. Your other equation, keep the left side the same. Notice in all of the absolute value equations we've done, we keep the left side the same. The right side, we need to take the opposite. We need to take the opposite of everything on the right side. So instead of positive 7x, we will have negative 7x. And instead of minus 16, we will have plus 16. Take a moment and solve both of those equations. If you're watching the video, pause the video and solve them. To check your solutions, you are going back to the original equation. Never check your solutions in the two equations that you wrote because that's where the solution came from. It will definitely work in those. You have to go back to the original equation. So we are going to plug the solutions into this x and this x and see if we get true statements. If you plug the solution in and you get a true statement, you're good. If you plug it in and you get a false statement, then that is not a solution. And a lot of this you can do with mental math or grab your calculator. You're plugging into 3x minus 4. So plugging 3 into 3x minus 4. 3 times 3 is 9. 9 minus 4 is 5. So we would have the absolute value of 5 on the left. On the right, 7 times 3 is 21. 21 minus 16 is 5. Does the absolute value of 5 equal the absolute value of 5? Yes. So x equals 3 is a valid solution. Now we plug in 2. 3 times 2. Do I need to actually draw this out so you can see what I'm doing? We're doing 3 times 2 minus 4. And 7 times 2 minus 16. 3 times 2 is 6. 6 minus 4 is 2. 7 times 2 is 14. 14 minus 16 is negative 2. Now you might think, oh, wait a minute, those aren't the same. But what's the absolute value of 2? What's the absolute value of negative 2? 2. And does 2 equal 2? Yes, so that is a solution. Sometimes both solutions work. Sometimes only one solution works. Sometimes both solutions don't work. It just depends on the problem. So basically, if you have absolute value of stuff equals absolute value of other stuff, you set up two equations. The first equation is stuff equals other stuff. The other equation is stuff equals the opposite of other stuff. You solve both equations, and then you check the solutions back in the original equation to see if they actually work. Do you feel like we need to go through this example, or are you good to go? Good to go. Here is your assignment. It's probably the easiest set of problems, not necessarily easiest, just instead of this problem and then this other problem, it's just 12 through 30 evens. That's pretty simple.